All right. So now we're solving for cases where there is a variable outside of the radical. Our steps are still going to be the same to begin. I'm going to say that, well, if I have the square root of 2 minus m, then 2 minus m has to be greater than or equal to 0. Negative m has to be greater than or equal to negative 2. And when I divide by the negative to get the m out, m has to be less than or equal to positive 2. There's my restriction. Beyond that, the steps are still the same. The radical is already isolated, so I'm going to square both sides. And I'm going to say that m squared is equal to 2 minus m. Well, now I can see that I have a quadratic equation, not a linear equation. So I'm not just going to be able to solve m just by putting it by itself. I'm going to use my quadratics method and move everything to the left side of the equation. M squared plus m minus 2 is equal to 0. I can see if I can factor this, and I'm going to state that m plus 2 and m minus 1 equals 0, which means that I have two possibilities. M can either equal negative 2 or positive 1. When I'm verifying, I need to verify for both cases. So I'm going to start by saying, well, if I have negative 2 is equal to the square root of 2 minus negative 2, then negative 2 would equal the square root of 4. Negative 2 is equal to 2, because remember, unless it says plus or minus, we're just taking the principal square root. And this does not work. So I'm going to circle this and call it an extraneous root. The other possibility, if I have 1 is equal to the square root of 2 minus 1, then 1 is equal to the square root of 1, 1 is equal to 1, and the 1 is my correct solution. When I get to example 2, start off the same way. I'm going to say that 5 minus n has to be greater than or equal to 0, which means that n is going to be less than or equal to 5. There's my restriction. And when I go back to my equation, well, I'm going to make the radical positive by moving that over to the right-hand side. I'm going to move the 7 over to the left-hand side, and I'm going to say that n plus 7 is equal to the square root of 5 minus n. This is where I said that we need to put brackets around, because if I have to put brackets around, remember, when I'm squaring the left-hand side, because it's a binomial, it's going to square out to a trinomial solution. It's not just going to be n squared plus 49, it's going to be n squared plus 14n plus 49 is equal to 5 minus n. When I move everything together on one side of the equation, I have n squared plus 15n plus 44 is equal to 0. Or I can say that I have n plus 11 and n plus 4 are equal to 0. So n can either equal -11 or -4. Let's check these possibilities. So if I have -11 minus the square root of 5 minus -11 is equal to -7. -11 minus the square root of 16 is equal to -7. -11 minus 4 is equal to -7. -15 is not equal to -7, which means that that's going to be my extraneous root. For the second example, -4 minus 5 minus -4 is equal to -7. -4 minus the square root of 9 is equal to -7. -4 minus 3 is equal to -7, or -7 is equal to -7. And that one works, which means that that is correct. Okay, and let's take a look at this last example. So, to start with, 2x plus 3 has to be greater than or equal to 0, which means that x is going to be greater than or equal to -3/2. I'm going to do the same thing I did last time. I'm going to move the radical to the right-hand side. I'm going to move the 6 to the left-hand side. And I'm going to state that x minus 6 is equal to the square root of 2x plus 3. I'm going to square both sides. And I'm going to say that x squared minus 12x plus 36 is equal to 2x plus 3. That x squared minus 14x plus 33 is equal to 0. And I have x minus 11 and x minus 3 are equal to 0. So x is either going to equal 11 or 3. And now we have to check them. So I can say that 11 minus the square root of 2 times 11 plus 3 is equal to 6. 11 minus 22 plus 3 is equal to 6, or 11 minus the square root of 25 is equal to 6. 11 minus 5 equals 6, and 6 is equal to 6. And that one works. Alright, and let's check the other one. If I have 3 minus 2 times 3 plus 3 is equal to 6, or 3 minus the square root of 9 is equal to 6, 3 minus 3 equals 6, 0 equals 6. That is not true, which means that 3 is going to be my extraneous root. So 11 is my correct answer, 3 is my extraneous root.